All right, let's get started. So today, I was thinking we would go over the exam problems and just, talk about them a little bit. In terms of when the exam is going to be graded, hopefully we can get about a 1 week turnaround on the exam problems. I was thinking of writing some kind of script to grade things, but I think we're definitely going to just have to have TAs look at each problem. In terms of partial credit, in terms of all of that stuff, if your code doesn't quite work, then a testing script would just give you a 0. So we need to have TAs look at all people's code and just kind of give it a number based on the relative effort that was put in and how close you are to the right answer and that kind of thing. Okay. In terms of everything else, yeah, let's begin by talking about the exam itself. Okay. Okay. Let's pull up Python. Where is that? Here it is. Okay. Cool. So let's go and let's just make some new Python files. Let's say, okay. So let's begin. So what was the first problem? So the first problem was almost palindrome. So here I basically describe what an almost palindrome is. It basically is just a palindrome where some pairs are allowed to have errors. So what we're going to do to code the function is we're going to copy and paste it into here. And so here we're going to have the string is going to be the string we test as an almost palindrome, and then the number of errors is the max number of pair errors we can find, and it's going to return true or false. Okay, so how do we code this up? Well, how do we code up a regular palindrome recursively? What we do is we say, well, if the length of the string is empty, right? So if this is equal to 0, you can also say things like, not the string or not lend the string. If you do either any of those, then you can return true, because you see the string, if it's of length 0, empty string is a palindrome. Yeah, I would say that we're probably going to use most of the class for exam 2 review and project 2. So, okay, else, what else do you do? Else you return, well, let's say elif the string 0 is equal to the string, and we can use negative indexing, right? This is the last element. Yeah, I guess no one really cares about that then. Okay, so if this is equal, we can return almost palindrome. The string 1 to -1, and then I guess we need num errors. Else return false. Okay, so this is the almost palindrome function. All right. So how do we fix this to make it the almost palindrome function, right? So this is actually just coding a palindrome function. So the way that you can fix it is, what you do is you say, basically this is all you have to do. You say elif this thing, well, basically you can just say elif num errors is bigger than or equal to 0. You can return this with num errors of -1, else, return false. So that finishes the problem. So this problem was a, I mean, granted, it took me about 5 minutes to write it. I think in order to code it, it's, you know, so that's kind of it for this problem. You know, and I also had the recursive palindrome code on GitHub, so I expected that this problem was going to be simple, but apparently people hated it. Okay. All right, so let's move on to the next problem. So what was the next problem? Ah, yeah, the square problem. There was quite a bit of confusion that resulted from people, I don't know, people didn't want to seem to read or whatever, because we got so many questions. This is basically the same text. I think I modified it a little bit. I think I added this after I released the exam, just as a bit of clarification. But I mean, this was in the test document since the beginning. The grid is a two-dimensional list. I think 80% of our questions about this problem was just like, is the grid a two-dimensional list? And I don't understand, because it says the function will be set a 2D list. I don't know. Then again, I really don't understand very much. So, you know, who knows? You know, you guys can tell me why I'm crazy. Okay. All right. So let's make it. Let's see. We want to make find a square. And so in order, basically, the grid is, I think the simplest possible solution is just for I in range len height -1, for j in range len width -1. And then what do we have to do in here? So we have to figure out what a square is. Yeah, it is true if the number of errors is equal to 0. You see, here's bigger than or equal to 0, right? And if we get down to 0 and the thing is bigger than or equal to 0, then it'll return true. I'm a little worried about that. Yeah. Okay, so, you know, I considered making this the interesting problem, where instead of just finding a square of size 4, where it was literally just go down 1 and go over 1 to find a square, basically, let's make an example grid. So if we have like test grid 1 is equal to this thing, let's say empty star empty, and then we'll make the second line the same thing, and then we'll make the third line basically just all empties. So this has 3 rows and 3 rows and 6 columns. So what we can do here is we see that a square is going to be something where if it's at this coordinate ij, then it also has to be at I plus 1j. So this is I plus 1j. This is j plus 1, right? So I and j plus 1. And then this is I plus 1, j plus 1. So basically, you can basically say just like if the grid at I, j is equal to star, and you could have defined this as a constant, is equal to the grid I plus 1j is equal to the grid I, j plus 1 is equal to the grid I plus 1, j plus 1. Now you can separate this out, return ij. And then return an empty list if you don't find anything. So the point here is that in terms of this one, and you could have separated this out into a bunch of different things if you wanted to. You could have made this multiple if statements, but I kind of just smashed it all into one. So let's see, what does this return on test grid 1? hopefully this does the right thing. Oh, I forgot. Okay, 3.6. Cool. Int object has no length. Oh, wow. I forgot that I was... Yeah. Okay. Fixed. So is this right? The answer is, well, at row 0, this is position 0, position 1, position 2. And there we go. So we found it. I guess we could also do a test grid 2 where everything is empty. I'll make it the same size so that I don't have to screw around with these parameters. Cool. So after those 2 tests, we know that this thing works perfectly, right? I mean, not really. It's possible that it could screw up, but I think it's correct. Okay. So let's define this as and then tab everything in. Okay, so what was the last problem? Oh, this countries and cities problem. Yeah, so this was just another, you know, figure out how to make a class thing. So let's do this, copy paste, fix that. Okay, so what are we going to do here? So the first thing you might need to do is add a constructor. And then the next thing you want to do is we'll have, say, self.countries is some dictionary. So if we're going to add a country, then what we'll do is we'll say self. If country name not in self.countries, then we'll just add it. And I'll make it an empty list, and I'll return true. Else, there we are. So that's all for that one. What about add city? So for add city, all you really had to do was say, well, if country name is in, whoops, self.countries, then what we can do, well, so should the first function always be an init? The answer is you don't always need a constructor in Python, but if whenever you create one of these objects, a cities and countries object, you want this dictionary to be created, it's good that you create the constructor there. Because this will make sure that this variable is defined whenever we use it. If you didn't create the variable in the constructor, then it could just not exist when we get to this function. I mean, the short answer is yes, as you say. Okay, so we go self.countries, country name, dot append, since I have it as a list, city name. So we can say if city name is not in. There we go. And then we can return true here, and then we can return false here. So anything you define in a constructor, if you put a self dot on it, so if I just say like x equals 3, x is a local variable inside this function, and it dies as soon as the init function ends. But when I do this, when I create this new variable, yeah, you were supposed to use dictionaries. Look, you know, this dictionary right here. Why don't you need countries in the parameters for the init function? Because I mean, you could have like a list of starting countries if you wanted. So if you have like, you could do something like this, but that wasn't how I defined the class, and that's not how the test code worked. So I don't need it. Okay. Okay, cool. So then for find city, there's really not a lot to this. This is just something where you would say something like, if country, or I guess, oh, right. For country in self.countries, if city name is in self.countries country, then we'll have some list, right? We'll have result list equals new list. And remember what it has to do. It's a list of the countries that have this city. So what we want to do here is just go result list dot append, not city name, but country, and then return. There we go. So technically, this is all you had to do for this problem. I guess it's the longest solution, but it's also, I think, kind of the most follow your nose solution. It's kind of the most straightforward. So does the constructor define class variables? Yes. So what I'm going to say is that it defines instance variables. So the difference between a class variable and an instance variable is instance variables are unique to each instance of the class. A class variable, if you ever see that term, is a variable that is shared among all of the classes of that type. So all the things, so we create instance variables in here, technically not class variables. Now, I'm never going to be that specific in terms of what I expect you guys to know. And all I'm saying about class variables is that, so if you want to declare a class variable, here's how you do it. Here's blah class var equals a new list. And so I'm going to show you why this is a little bit dangerous. So we're going to have x equals cities and countries, y equals cities and countries, right? And then we're going to say x dot add, say add country, Moldova, y dot add country, or no, add country. What's a good country? Italy. Y dot add country. Okay. So this didn't work? I'll test it out. Let's see if it does it. Okay. Yeah, okay. So let's call this. Let's put all of this in here. Let's test. Let's see. Does that return true? Shouldn't. I guess maybe if the thing is let's see if that fixes that. I'm not sure if it will. Okay, so I have to test it. Oh, wonderful. So we need to keep this. If this is equal to this, then we return this, which is correct. If the number of errors is bigger than or equal to 0, then we return this. Otherwise, false. Okay, so where did I screw up here? Oh, I guess since it's, fixed. better. Yeah, so yeah, you just have to test if num errors -1 is bigger than 0. That's better. Really, I should have just said if num errors is bigger than 1. Because here we're subtracting, and so technically if you start out with 0 num errors, you'll get -1. And so anyway, that fixes it. Okay. Let's see. Let's just test to make sure it works on ABA. Yep. Cool. Okay, I think I fixed it. Yeah, you might want to test. So I guess you could always say elif like num errors is like less than 0, right? So if somehow someone enters in a num errors, like technically this isn't necessary unless the user enters a negative number to start. So, I mean, we're not going to do that. We're not going to test. So the reason why I kind of write this a little bit sloppily is that we're not going to test you on a lot of different like edge user input cases like that. Like that was not the point of this. You really don't need this unless, of course, you assume like the user might enter -5 in just to start, because then, of course, but actually it might. Well, no, it wouldn't catch it if you have an empty string with num errors -5. I guess that should return false regardless. But anyway, okay. So I wanted to show you guys the example of class variables and why it's a bit confusing. So here, if I print out x.countries, and here I print out y.countries. Let me do test cities and countries. So here we're going to see, here in the x class, we just print out Moldova. And here we print out Italy and Venezuela. So clearly, this self.countries is a different variable, right, inside of the x class and the y class. So in this x instance, I should say, this x instance and this y instance, they have their own self.countries little variable. On the other hand, what did I call this thing? Yeah, blah class var. So if I say, okay, well, is that the same as doing x dot blah class var dot append, let's say argle, and then y dot blah dot append bargle. So you might think, oh well, the countries variable was separate for x and y, and there's not an obvious difference here between something declared here and something declared here. So you might think to yourself that that this also would be its own class in each instance. And so the problem with this thing is that if you actually, let's print it out. So x dot blah class var, and you would think like, oh, it's just going to have argle in it because bargle got appended to y. So, you know, it shouldn't be in there. But we see that actually they're the same. So this should return true. So remember what the almost palindrome example said? It said that this function should determine if the string is an almost palindrome with, and then here's the important thing, at most num errors. So if I have one error to go, but we don't find any errors, then it is essentially an almost palindrome, right? Will you need class variables in 201? The answer is no. The only reason why I'm talking about them like I am is because sometimes, especially in the future, when you go online and you ask, like, oh, how do I use classes? Let's say you forget how to do classes, and you find some examples of classes. I've seen a lot of bad example code on the internet where they create all these variables up above the init method, and they don't mention that these are class variables that are shared amongst all the instances of that class. And so because they don't say that, it's very easy for especially programmers of other languages. In fact, when I was learning Python, that very thing screwed me up for about 3 hours because I didn't know that without any special notation, you could create a class variable like that. So there's ways to do that in other languages. So in C++, you can add something called static onto a class variable, or onto an instance variable, and make it a class variable, basically. It's how you do it. But you have to actually intentionally do that. But in Python, if you just declare the thing right outside of the thing, then it won't know. Okay. So yeah, because here ABCBA has 0 errors, but we have 1 error left free, which is okay. All right. So, okay. Cool. So that was, those were the coding problems. Let me see if I can find the testing problems. I think where I stick them. Good question. Random scripts? Nope. Nope. Maybe it's in a different project. Let's see here. Interesting. Where would I have stuck? Let's see. Okay. Whatever. Let's just pull them up from the GitHub. That'll save time. Okay, and then let's do the debugging problems. So, all right. Okay. All right, so here's the first debugging problem. So, okay. Basically, what we wanted to do was we wanted to sum up a list. So if the way that you should think about it is, like, let's say that we had the list, say 3, 4, and 5, and we want a sum, our goal is 8. Then what we want to do is we want to pick 3 plus 5 is equal to 8, right? And if we have something, let's say 10, so if instead of the 8, this is 10, then there's no way to make 10 from this, right? Because this gives us 3 plus 5 gives us 8, 4 plus 5 gives us 9, 3 plus 4 plus 5 gives us 12. So if you want to make 10, then we see the problem here. The thing is that, well, if we take 3 plus something, then we want a sum of 7 left. If we don't want to take the 3, then we just say, okay, what happens when we don't take the 3? Then we either have 4 or 5, and we want a sum of 10, right? So, and so if we go down the path where we took the 3, then what's going to happen is either we take the 4 or we don't. If we take, so this is 3 plus 4, and so then the sum that we want, and then we're going to have plus maybe 5 or not. And so we want a 3 left, and so you see that here, it doesn't matter if we take it or not, it won't work. On the other hand, here, a 3 plus, if we don't take the 4, we'll end up with 5, and we still need 7 left. And then here, we'll see that if we take the 5, if we don't take the 5, we just have 3 with 7, so it's not equal. And if we do take the 5, then 3 plus 5 is 8. which is not equal to 7. So neither way do we get the solution. Same thing down here. So you can basically go through all the possible options here, and you'll see that you can't get 10. Okay. So let me move this comment above the code so that it's not in the way. So the point about this one is that if the goal is equal to 0, so we return true. There's another base case that you had to add. The other base case what if my code doesn't work for 1, 2, 3, 4? I don't know. I'd have to look at your code. So there's two possibilities when you could reach the end. The first possibility is you have some stuff left in goal, but you haven't reached 0 yet. The other possibility is you don't have anything left to add, but goal is not 0. So basically here, elif not my list. Return false. So what that means is that goal is not equal to 0, right? Because that otherwise it would have done it here. Elif, so what this says is if the list is empty, but goal is not empty, then we have to return false because, because that means that we need a certain amount more, but we are never going to get that amount because we're never going to get that amount because our list is empty. Okay. And then, if I'm not mistaken, the last error is you just have to change this to 1 and change this to a minus. Because the rest of the list is my list 1 blah, not 2 blah, right? And the last thing to do, so basically here, if you wanted to add the comment, you could say, we need this in case we run out of numbers in the list, but still need more in our goal. And then here, you just have to change the plus to a minus. Because here, the thing is, once you take something, right, you don't want to add it to the goal, you want to subtract it from the goal, because the goal is less now, given the fact that we just subtracted off the thing. If you add it to the goal, then that means that the goal is increasing as you're taking numbers, and that can't be right. So basically, those are the modifications you had to do. You had to add this base case back in, and then you had to change this, because this was 1 colon, this also had to be 1 colon, and this had to be my list 0. I'm sorry, this had to be minus, not a plus. So that was the real hard error. So I would say this is the hard error to find. But that's it. I think I said something like half the points are going to have to be for the fix and half the points are going to be for the annotation. I mean, at least you have it. I think you'll get the most of the points for the problem if you fixed everything else. Yeah, I mean, so here's the thing. I took working code for these, and so you see that I had to add 2 lines, right? And one of them is an elif, and the other one is just a return false. So this is, I mean, really, this is hardly even a line of code, right? This is like a quarter line if you're really being finicky about it. There's not a lot here. I consider this a line of code. So you have to add like 1.5 lines of code, essentially. And then you have to change this number to match this number. And then you have to change the plus to a minus. So, yeah, no, I mean, a lot of people completely rewrote everything because as I say, I took working solutions and modified them slightly to not work. So that's kind of the idea here, is that there's a shortest path to the solution, which I definitely know because I was the one who wrote the solution and then changed it. So, I mean, granted, it's a little bit cheaty for me to solve these problems so quickly because obviously I knew exactly what I'd changed. But yeah, so the thing is, like, I hadn't written up any solutions that were like garbage and then made them slightly, less garbage. Yeah, I mean, I tried to explain it in the problem so that people would have some idea of like what, what this thing was actually doing. Okay, and then let's do the last problem. Let's see here. Oh yeah, and no one liked the dictionary in this problem, and I don't know why. I mean, so I made this. So okay, here's this stupid fix. Change to lower. So that's a freebie. So here we're just counting up the letters. The one thing that you have to do, oh yeah, and I did this for both of them. So if the letter is not in the dictionary, you have to put an else in here. You have to say like first word dictionary letter equals 1. And then you have to add the identical thing. So this is if it's not in the dictionary of letters already. And then here, I have to do the same thing for second word dictionary. If you've already commented it up here, I probably won't care if you comment it again. So the reason why is because here, if we're adding 1 to something that's not in the dictionary, then it's not going to work. So we have this if statement. And so really, I had an idea that I was going to just return, so you have to basically copy and paste this and just check this as well. Otherwise return true. So this is one way to solve the problem. Okay, why is second word not being used? There we go. Minor fix, change. And so here we have to check that all letters in the second word are in the first word. Okay. So, and the hint of that is that if you were doing this in PyCharm, the second word had a little warning under it that was like, oh, it's not used, which should tell you that there's something wrong. And the thing that's wrong is that here you see for letter in first word, and here it was like for letter in second word dictionary. So this is all you had to do to fix this code up, really. Now, there's actually a way better solution than this. So really, this is pretty garbage. The best way to do it would just be to say, and then to delete all of this. But you didn't have to do any of that because this was just a debugging problem. You wanted to pretend like this was someone else's code, and you were just trying to fix it for them, not trying to like optimize it necessarily. But yeah, if you get rid of all of this, then you can just this return is enough, because this is actually going to run both of these checks for you and make sure that all the key value pairs are the same. So, yeah, I was seeing that in a lot of people's code in various things when you're using dictionary. So here's the thing: when you're going through a dictionary, when you ask like, "Is blah in a dictionary?" the question is not "Is blah a value?" It's always the question is blah a key in the dictionary? If you want to know if it's a value, then yeah, you have to say is blah in dictionary.key values. But generally, you don't want to do that. Otherwise, like the point is that you shouldn't really be caring as much about the values as the keys. The values should only matter if you know what the keys are. So for instance, like I always like to say, if you know, like if I say, okay, there is a grade in this class which is 89, right? So someone has an 89 in this class, right? But that doesn't matter to you because, well, I mean, who cares, right? There's so many people in the class that it's irrelevant. The real question is who has the 89, right? That would be the key. The student identifier would be the key. The grade could be the value. Yep, yeah, so individual letters are the keys, which is what we're doing here. Yep, so yeah, that's exactly what this does. Yeah. Yes, exactly. Exactly. That is correct. Okay. All right. You know, a better way to do this, I hadn't even, well, so the reason why I made this problem this way was so that it was kind of obvious what I was going for and that none of the fixes would be very hard. If I had made the problem a little more optimized, then it might have been a little harder to solve. So I think, like if you really wanted to do this a little better, you could always just say, you know, for a letter in first word or something, you could say like, so if we have like a letter dictionary, you could say something like, if letter in letter dictionary, then you can just do letter dictionary letter plus equals 1, else yep, equals 1. And then what you can do for the second word is you can actually do something like this where you, so if you do something like, you can actually just subtract off, and so equals -1. And so basically then you can just ask, like, for letter in letter dictionary, if letter dictionary at letter is not equal to 0, you can just return false. So this is a slight improvement because technically now you only need one dictionary instead of 2. But I mean, really, it doesn't matter. The whole point about this problem was not that doing this thing was complex. It was just trying to get you to make the code work in a kind of symmetric way. Does not break the code when you try to search for an invalid key. I assume what you mean by invalid key is that a key that's not in the dictionary. I'm not sure exactly which part you're referring to, but I'm going to say most of the things in here. So for instance, here, if I say if letter in letter dictionary, that will not break it if letter is not in letter dictionary. It'll just return false and it'll go into the else, I think. Okay. All right. So, wasn't that fun, right? Everybody loved this exam so much. There were no complaints about it. Everybody just said it was the best exam they'd ever taken. Yeah. I think that's what happened. So anyway, yeah, I mean, so, you know, as I think I was just about right. It took me what? 45 minutes. But if you take out all the time for testing and you take out all the extra time, it took me about, let's just say, 30 minutes to write the solutions down. And so, generally there's like a rule of 4, which says that whatever time it takes you to like write down the solution, you estimate it's going to take people about 4 times that long, so that'd be 2 hours. So that's why I gave the estimate of like 3 hours. I was just like, I'll just add an hour to that as an estimation of people running tests and doing other stuff like that. I hear you. I hear everybody when you say it took you. You know, when I say the words that I'm saying about the test, and I say, this is how the estimation is generally done. I think, yeah, there was a great deal of perplexity and confusion going on. Well, I mean, so to respond to you, D, it did include way more sample output than on any previous exam, as it turns out. So all the previous exams on paper would only have exactly one test case written out. So, and I always hated that. I thought, okay, I'll provide you guys with 3 or 4 different sample outputs, and that'll make everybody happy. But I mean, clearly, it did not. So, okay, that's all about the exam that I want to talk about. I mean, was this exam hard? I guess it was. See, I when I was writing it, I thought to myself, it's an easy exam. Everyone's going to get an A, and then they're going to laugh at me. So, that's usually what I think, is that, people are just going to be like, you see, this exam was too easy, so you're an idiot. And that's what goes on in my head. I think that everybody was doing a great deal of overthinking. Not just nobody was doing a great deal of overthinking, but everybody. In terms of curving this exam, it is not impossible. I haven't checked the multiple choice grade yet. I will check it. Everyone's gonna fail. Were you gonna cry? Yeah, I guess I'm so afraid of people laughing at me. Am I also afraid of people crying at me? The answer is yes. I'm equally afraid of both. So don't cry. We're gonna see what the grades are this week. We'll get a good estimation pretty soon. It is not an impossibility that there will be some kind of curve on this. But of course, the curve has to be determined by the average performance. So I cannot say that there will be a curve or not, just because I do not know what the average is yet. Actually, let's check and see what the Blackboard says about the average on the multiple choice. I think it's going to be low. Let me do it off screen so I'm not sharing a ton of students' private information. You'll just have to trust me that it's the average. Let's see here. Exam 2 multiple choice. It looks like actually it looks okay. Looks okay. More or less. I mean, yeah. I would say the average is somewhere in the... So there were 24 points. A lot of people got 24s. The average is somewhere in the 18 to 21 range. That's good. I mean, I was worried that the average would be very low, but as it turns out, so what's 18 out of 24? So 18 out of 24 is a 75. So the average, I'm going to say, is definitely above a 75. And so, yeah, okay, cool. now that I've done all of that, I think that I've tortured you guys enough with that. So let me try to find what I'm thinking of finding. So I think I did it in a different project. Yeah, okay, here it is. There we are. Okay, so, all right. So let me talk about testing, because that's the question that everyone has. So let's say, for instance, that we're going to make a Pac-Man game. So here's the idea. Like, if I'm going to make a Pac-Man game, like, what is Pac-Man, right? It's like a grid, so it's kind of like the thing that that we were dealing with, except what? Basically, so let's just say that I don't really know how my project is going to be implemented, and you see here that I haven't really done anything. But all I do know is that there's going to be some play game function. There's going to be like a load map function, right? Because Pac-Man has a lot of walls and stuff that you have to deal with. And then there's going to be like a move baddies function, which will move the bad guys. And let's say that there's a check move function. So say like X and Y are passed in as parameters. And let's even pass in the board, right? And so let's say that we have a list of baddies. Yeah, okay. And let's pass in the board and baddies for this one. For play game, really, maybe nothing needs to be passed in. So we might not test with this function. And so for this one, what we might do here is, let's just say take turn is going to take the board. And load map is going to take a map file. Okay, so that's fine. So here's the thing. We may not know anything about what we're actually going to do to code this project, but we do know some things. So for instance, what this is going to do is it's going to take in a file name, and it's going to return, let's just say it returns a board. So it's going to be a 2D list, which is the grid. And so the idea here is that I don't know what this thing is going to do, but I do know that it at least needs to return this thing. So let's pretend that I'm going to create a new, let's say, file. Let's call it testboard1. And let's make it a text file. And so let's call the testboard something where it's just all, let's say it's all walls, right? So there's nothing in it. There's no bad guys. Let's say that a bad guy, you know, starts with a B and the player starts with a P. So something like that, right? So maybe it'll be this. Well, so here's the thing. I don't know much about the load function. But what I'm going to do is I'm going to say from the Pac-Man project import Pac-Man. Now in PyCharm, you may see these red underscores. The reason why is because it'll say something like unresolved reference to Pac-Man. But as it turns out, if I run this code, it runs. Which means that actually there's something up with PyCharm. It thinks there's a problem here, but it doesn't actually understand that it's just looking in the same directory, which Python does. So Python will look inside of your Pac-Man project file here, and it'll import the class Pac-Man. And so this does work, right? Even if it's red underscored. So, okay. So now here's the thing. This is using a bit of object inheritance, but this is one way you can do it. So the other way you can do it is just say like test load map here. And what you can do is you can create a new Pac-Man class. So P is equal to Pac-Man. And then what you can do is you can say like p.theboard, or let's say p.load, what is it? What's the file called? It's called load map. And then we'll say like test board 1. And then the idea here is that it's going to have to be equal to, I think, what was it? Star, star, star. Oops, that's a lot of garbage. Star, star, star. And then it's like that. And then I think it had a baddie in this place. And then the player starts here. So if this is equal, then we'll just print out, you know, something like that. So then we keep going, right? So then we're going to say, okay, now there's going to be another board. So when you load test board 2, let's say that we get, you know, I don't know, say that board is different, right? So say it's this shape. Yep, let's do this. Let's say it's basically a U. And so let's see, what should the, I guess we're not even coding in food. This is, we just have players and baddies. We'd have like the end, I suppose, or something. Anyway, so whatever that test file looks like is what you should end up testing it against here. And so you might end up having to make your test boards before you even write your load map code, which is completely fine, right? So that's the idea here, is that this is what you should do for like a test of a load map. Now here, what you can do in terms of like, say, move baddies. So if we're going to test them, then what we're going to do here is we'd say, okay, so the function takes the board and it takes some baddies. So what we would do is we'd say like, okay, P is equal to Pac-Man. And then instead of loading the board from a file, you can even just do like p.theboard is equal to, and then you could just set it equal to this, for instance, right? So literally just set it into a board. And then, for instance, you might run the p.move baddies function. And then it would, I guess actually it would be like p.baddies, right? So it's the board, p.theboard, and p.baddies. You may not actually need these parameters. You might actually just be able to get away with just using the local members. So for instance here, you would have like self.theboard, and you'd have self.baddies. So the idea here is that what you can do is you can actually just run the test on this, and then you can say, well, if, you know, so you can actually just put the baddies in a specific position. So I'm going to say that you should have at least 4 functions that you're going to test. And you should, that's the whole point of this testing script business. So if you ask, like, why did we take the design out of the project and put in the testing stuff? The reason why we did that is because we asked a lot of people, or we asked people to write these design documents for all their projects. But then the problem was that everybody who did it, most of the people didn't really write design documents that looked anything like their projects, because they didn't think about what the function had to eat and what the function had to spit out, right? And so the difference between a design document where you basically write down the function and then explain in English what that function is going to do, so that's what we used to do in this class. And the reason why we're trying out this new design document, or this new testing script business, is because here you see it's not an English sentence. It's literally a line of code that you eventually want your load map function to work on. Now, we know that your load map function is not going to work, right, as soon today, because you haven't written your projects up yet. But you know that when you write your project, you're going to need a load map function, right? Or a load board function, or whatever you want to call it. And it's going to have to return the board in some way. Or it can set it to an internal variable. But for testing purposes, I would suggest that you return it as well, so that you can actually make sure that you're... So it's nice to have things returned. Like a lot of these class functions, you might not have to actually do anything. But here, you might actually consider just returning like self.theboard, right? And the reason why you want to return it is actually not because... So this is not because you're actually going to set it equal to something. But it's because you want this to, what should I say? Right, to be passed to the test functions, which is the secret reason that you might return something in this case. But it's actually good because it'll still get you in the practice of understanding like what things you want as a parameter and what things you want to be returned. So this is what I think we're going to do in terms of the test scripts. We're going to run the test scripts on your functions after the end of the project. So what we're going to allow you to do is you'll submit your test scripts now, but as you keep coding your project, you can update your testing function, and eventually the goal is that your test functions will all pass on your code. That's the idea. Now, so the idea is all your tests will eventually pass on your code. Now, if yes, I will probably do that in terms of giving more time. I maybe give you guys until Wednesday. What do you think? Wednesday? Uh-oh. Okay, I'm back. I think the stream glitched for a second. I didn't want to talk while the stream was glitching. Okay, but anyway. Yeah, so I mean, we've been extending everything. We shouldn't be doing that. It's very bad. But I'll do it. But you see here how this testing stuff is going to work, right? So basically, like, what is your move baddies function going to do? Maybe it returns like a list of new positions for the bad guys. So like new positions equals this. And then what you would do is you would say if new positions equals whatever the right answer is, right? So, you know, whatever. So I'm going to make an exception. And so if I give us, so we're not going to change the final deadline yet. The reason why is because the third project is going to end up being due on the Monday of the final exam week. So I really want to avoid moving the project due date itself, because if I do that, then we will be pushing the third that's the problem with teaching this course, is that this course is kind of timed precisely, and we can't push everything too far back. If we give too many extensions, then yeah. Anyway, but the point is that this is what I wanted to talk about in terms of testing. I definitely wanted to do this. And so you see here that there's another way to do the test script, and I'm going to upload both the Pac-Man project, which you see is totally incomplete, right? And also the Pac-Man test project thing. I'm going to upload both of these to GitHub. So project 3 is normally the recursion project. But we are thinking this semester of making project 3 into a kind of, let's say, a practical application of Python project where you do some kind of real world thing. So we'll teach you about modules. We'll teach you about, so 5 tests per function. Yeah, so try to make 5 tests per function. We're thinking of not doing a recursion project and making it something applicable. So like something like internet scraping, or I don't know, something with databases or something like that. That is the idea that Ben and I have been throwing around. So I will work with him to write that this week, and you'll get it next Monday. All right. So that's really all I wanted to say about testing and about, well, actually, let's describe what this thing is. So, what is internet scraping? Internet scraping is when you have like a website that has a bunch of data that you want to get from it. And so if you have like a website, say Wikipedia, say Reddit, say Twitter, Facebook, though Facebook's a bit harder to scrape because everything is private. Generally, in order to scrape Facebook, you have to pay them for some back-end scraping permissions. But anyway, but for like public websites where things are accessible, we might have you like scrape some of the data off of that website. We might teach you a little bit about like how to do that and how to store it in a database or something like that. We might just have you use dictionaries and files. I might, instead of doing a database, even though it would be very applicable, it might be hard for everybody to get the dictionaries, the databases up and running since it's like its own software. So we might end up just, you know what, I was thinking it, yes. We'll teach you guys about JSON, and you'll use JSON structures to store it in files. You can load and it's like a poor man's version of a database. So that's what we'll probably do for the project. Again, so that's the idea. Okay. So the last thing I want to talk about is object inheritance. So what is this class Pacman test with this Pacman in parentheses? And the answer is Pacman test is Pacman test is a child of Pacman. And so what does that mean? Estimated data project 1 and exam 2 grades. So I'm hoping that we can get exam 2 graded by next Monday. Again, TAs have to manually do it, so I don't want to rush them. Estimated data project 1. So as soon as project 1 is done, we'll start grading homework 6 in project 1. It does pile up on the TAs, and the TAs are students too, so we have to be conscious of that. I mean, we can. Yeah, that's all I really can say for now. I'm gonna have a meeting with the TAs after this class and try to determine what thing to do. Okay, so I'll get back to you guys on the return dates. All right, so Pacman test is a child of Pacman, and so what do I mean by that? What I mean by that is that in each of these functions, if I go normally, if I go self dot and you see, oh look, I can do self dot load map, and I can print this out. So let me create a Pacman test object. PMT. So PMT dot, I'll call the test load map function. And so you see how test load map is calling the load map function, and we're printing it. So let me run this test. Oops. Oh, does Pacman not have a constructor? Oh, it does. Aha. There we are. That's the problem. Oh, aha, now it changed colors. Okay, there we go. So require, oh, of course. Okay. So you see here that even though this class doesn't have a load map function, it does now because Pacman test will have all the functions of the Pacman test has all the functions that were in Pacman. So all the functions that are in Pacman are now secretly also included into this class. What is super? So super is basically saying whoever the parent of Pacman test is, which means Pacman. So if we actually print it out, for instance, like type of super. I think it should print out Pac-Man, or maybe just explode. Yep. Oh, interesting. That's interesting. So it's tricking us. It's not giving us the answer. That sucks. Anyway, yeah, it's super. Basically, this is just saying whoever the parent is, that's what it's referring to. So you see here is a constructor, and it's running another constructor. And so the question is, what constructor is it running? The answer is, it's actually going to be running this. So if we print out, say, Pac-Man constructor running, and then we run this thing again, what we're going to see is that it should print out that Pac-Man constructor is running. So that's what this is doing. It's finding who the parent is of the class, and then it runs the constructor of that parent. So this is, it's a bit of Python magic is what this really is. So honestly, if you want to do your tests this way, you're perfectly allowed to do this. The other way you can do it is just making functions like this. And if you make a function, then the first thing you should do is create your Pac-Man object. And then what you want to do is probably go like, you want to change the internal variables inside of the Pac-Man object. And then, so what's the purpose of parent-child classes? I think generally the answer of that is that you can always, so if you have some class and it says like animal, and that'll be the parent class, and so we'll have, what is it, vocalize, print, eek. And then let's say that we have a class dog, which is an animal, and then it'll also have its own, well, so, okay, so, yeah, let's def vocalize, and then we'll print woof. But let's say that we have class mouse, and we don't put anything into the class of mouse. So let's do this at the bottom of the code just so that you can kind of see what's going on here. So let's comment these out. And so the idea here is that what you can do is if you create, say, a mouse, you can do mini dot vocalize. Ooh, nice. I wonder if it's not going to work because, let's see here. Oh, it's not an animal. There we go. I was like, what the heck have I done wrong? There we go. So, but if we create pupper equals dog, pupper dot vocalize, then we're going to see the result of what happens here. So you see that a lot of times in life, this is kind of the generic example of things that you see a lot on a lot of different websites and a lot of different textbooks and stuff, where it's like, well, you have an animal, and the animal is, so this is a specific kind of animal, and this is a different specific kind of animal, and so each one of them has a vocalize function because the parent had a vocalize function. It's a way for like a simpler base class to share functionality with child classes. The other thing that you can do with it is if you have, for instance, if you have a constructor in here and you say self.name equals this, so then each one of these has to basically take a name. Well, yeah, you can definitely have a default animal. So, so you can just create an animal, right? So what's an animal that is some weird thing? So you can have a dung beetle, and you don't, it's not a dog or a mouse, you just create it as an animal. And so dung beetles, I guess, will also go eek, because that's what this does. Yep. Platypus, yeah. So basically that's the idea here. You can kind of play with this if you want, but again, I think I'm going to say you can play with this code or you can write your tests as just functions, as below. So yeah, that's kind of the idea here, is that and again, like, I don't really want to teach this subject, and of course class is over, but I also don't want to teach this subject because we've just added classes into this course, and I think that we've taught enough about them. I don't want to teach object inheritance because I think unfortunately it tends to confuse people, and so I'd prefer for you guys just to get a good handle on like what a class is, what an instance variable is, what a method is. Figure all that stuff out, right? Figure out about functions and return types, the basics of classes. The other good news is that for the vast majority of cases now, object inheritance is not as common as it used to be. It's kind of fallen out of favor in some circles. Should the project be one class? The answer is yes. All your methods should be stuck into one class. So that's why I did it here, for instance. Like, this is the Pac-Man project. If this were the Pac-Man project, this is essentially everything, right? Everything goes into here. And then basically your if name equals main for your project is going to be something like this. Whoops. Pac-Man, p dot, and then what is going to be play game. That's it. So basically, a method is just a function that sits inside of a class. In fact, in Java, in Java everything is inside of classes or interfaces. So that's not saying much. But in some languages, they don't make a distinction between a method and a function. I've just tended to use the term function. But yeah, you'll see sometimes people call them methods as well, especially depending on what language you're talking about. But if you just write like a function here, if you just say def blah fun, this is generally called, just a function. But if you write this thing, call me a method. So it's just a bit of nomenclature. I'm generally not going to test you on nomenclature. Okay. All right. I think that is the end of that. So maybe I will post some stuff. I'm going to wait a few days to post the solutions to the exam just because, I don't know. I'm going to do that anyway, but I will post those on the GitHub. I'm going to post the Pac-Man project and the Pac-Man project test on the GitHub. I'm going to delete this part here because I don't want to talk about inheritance. But other than that, all right, I'll let you guys go. So what is the main menu? So that's all explained in the project. I'm not gonna definitely read the project for that. So how do we test all of our functions only take self? Well, so yeah, if all of your functions only take self, then what you need to do is you'll have to do something like this, where in one of the tests, you'll have to configure. You see how here I'm actually just setting the local variables? I'm setting p is equal to a Pac-Man object, and I'm just setting the board and setting the baddies to specific things, and then you can run some test on that. So, yeah. So that's kind of the idea here, is that you'll have to set some variables inside of your class instead of passing it in as like the board and baddies, right? So if they're not taken as parameters, you'll just have to set them. All right. I think that might be it for now. Let us end the stream.